Welcome back! And the puzzle today is in a fast food. We are here ordering some meals, and the question is, what is the price of the combo? We have the price of the combination of a series of items, and maybe you can, by combining, by solving it, you can find the price of the combo. Try and see if you can manage to figure it out, and we will check the solution later at the end of the lesson. Today we are working on chapter 6, rational expressions, on section 6.1, rational functions and dividing rational expressions. The first objective is to find the domain of a rational expression, and the rational expression can be written in the form P over Q, where P and Q are both polynomials and Q is different from 0. A few examples of rational expressions: you have 3x squared plus 2x minus 4. This is a polynomial over another polynomial, 4x minus 5. I have a few examples here. All those are examples of rational expressions. How to find the domain of a rational function? To explain it in simple terms, you cannot allow the denominator to be equals to 0. That's how you find the domain. You're going to find the numbers or the values that make the denominator equals to 0. You will exclude from the domain. On this first example, we will have all the real numbers because 3 is different from 0. There's nothing that makes the denominator equals to 0. And the answer is going to be x such that, we can write in set notation, x such that x is any real number. Okay? You can write like this. Now the next example we have, now we have a different situation. We have the denominator x minus 1. What is the value of x that makes the denominator equals to 0? And we know that if x equals 1, 1 minus 1 is 0, and we don't want it. We will exclude x equals 1 from the domain. So the domain is x such that x is any real number different from 1. Okay? And C. Now we have this rational expression here. Don't worry about the numerator. Let's work on the denominator, okay? Because the denominator, well, the numerator is this. Don't worry about it. But look at the denominator: x minus 2x squared minus 2x minus 15. We can factor it out. We can write as x plus 3 times x minus 5, right? The values of x that makes the denominator equals to 0 are x equals negative 3 and x equals to 5. So we need to exclude those values from the domain. We don't want the denominator to be equals to 0. That means x such x different from negative 3 and let me squeeze here, x different from 5. Okay? This is how we define the domain of rational expressions, by making the denominator different from 0. Objective number 2, simplify rational expressions. To simplify a rational expression means to write it in lowest terms or simplest form. The fundamental principle of rational expressions are for any rational expression P over Q and any polynomial R, we can have something like that. P times R over Q times R can be written as P over Q times R over R, and R over R is equals to 1. That means we can simply, if you look here at the bottom, we can simply eliminate or cancel R with R, and you can say PR over QR equals P over Q. That's the principle of the simplification, how to work out simplification with rational expressions. And step by step. First, completely factor the numerator and denominator of the rational expression. Second, divide out factors common to the numerator and denominator. And this is the same thing as removing the factors of 1. And warning, pay attention, only common factors can be eliminated from the numerator and denominator. Make sure any expression you eliminate is a factor. Okay? And you will see on the examples what we mean about it. To factor out the polynomials, we can apply the AC method. And if you don't remember AC method, we have A, B, and C, right? A times C is -4, B is 3. We need to find two numbers that multiplied is equals to -4. This looks like two numbers multiplied equals -4, and the sum is 3. Well, we can have 4 and -1. 4 and -1 is a good combination. If you multiply 4 times -1 is -4. 4 plus -1 is 3. So the numbers 4 and -1. So you can factor out this polynomial as x plus 4 times x minus 1. Right? And we can use the AC method at the bottom. And we have 1, A is 1, B is -1, and C is -20. Right? So AC equals 1 times -20, -20, and B equals -1. You have to find two numbers that multiplied equals to -20, and the sum is -1. You can try a few numbers, but at the end you're going to say, okay, -5 and 4. Yes, -5 times 4, -20. -5 plus 4, -1. So right here, x minus 5, x plus 4. This is cool because check this, check it out. Let me just erase this thing so we don't make any mistakes. We are done. We use the AC method. Now the result is this rational expression here, and we have factors because factors are kind of polynomials multiplied by other polynomials. Those are factors. And we have x plus 4 is identical to x plus 4 on the denominator, right? We have both on the numerator and denominator. We can cross out, we can cancel. And at the end we will have x minus 1 over x minus 5 as the answer to the simplification of that rational expression here. Okay, now check the next one. And this is a very interesting one. Look, 7 minus y over y minus 7. They kind of look the same, but not in the right order, right? It's not exactly the same. Well, one thing that we can do is factor out -1 from one of this expression, the numerator or the denominator. So factor out -1 from the numerator, and then you will have y minus 7. Okay? And on the denominator, you will have y minus 7. Look! Now you have common factors. You can cancel, you can simplify, and the answer or the result is -1. Okay? Another example we have here x cubed plus 8 over x plus 2. And last section we worked on special case factoring, remember? And we have a formula that is for the sum of cubes. If you have a cubed plus b cubed, this is equals to a plus b. This is the formula. Check your formula sheet. You don't need to memorize, but you need to remember that the formula exists. ab plus b squared. And we will apply here because x cubed is a cube, right? And 8 is 2 cubed. Divided by x plus 2. So let's apply this formula on the numerator here. And let me have some space here. This is the formula. You need to have in a formula sheet. You need to remember the formula exists. And now we will apply on the numerator. So x plus 2 times x squared plus 2x plus 4 over x plus 2. Why all this trouble of remembering the formula and factoring out? Because now we can simplify. Check this. We have common factor x plus 2 and x plus 2 on the numerator and denominator. And the answer, after we do the simplification, is this. X squared plus 2x plus 4. So the rational expression is simplified, and this will turn into x squared plus 2x plus 4. Next example, I have 2y squared plus 2 over y cubed minus 5y squared plus y minus 5. And we have to apply some factoring techniques here. First, we can factor out. On the numerator, we can definitely factor out 2, right? So we can write here 2 times y squared plus 1. Okay? On the denominator, we have polynomial with 4 terms, and we can apply factoring by grouping, where we divide it in 2 different groups, two pairs, and then we factor each one separately. So this first one we can factor out y squared, y squared times y minus 5. And the second we can factor out just 1 y minus 5. Now on the next step, check and try to understand what you're doing here. Just repeat the numerator, and on the denominator, check this out. We have y minus 5 and y minus 5. We can factor out y minus 5. Check this. Y minus 5 times y squared plus 1. And this is very cool because we will have a common factor here. See, y squared plus 1, y squared plus 1. We can just cancel, we can simplify. And the answer is going to be 2 over the denominator y minus 5. So this expression, after we work out the simplification, will turn out to be 2 over y minus 5. Next objective, number 3, multiplying rational expressions. And the rule for multiplying rational expressions is, if you have the rational expression p over q, you're multiplying by the other rational expression r over s. This is going to be equals to, then you're going to multiply all the numerators and draw here a long line, and you multiply at the bottom all the denominators. This is how you work out multiplication of fractions, right? The same thing you apply to multiplication of rational expressions. Step 1, completely factor each numerator and denominator. Step 2, use the rule above to multiply. And step number 3, simplify. I think the hard work will be here. The multiplication is kind of simple, but you have to factor out and simplify to find the simplest rational expression possible. Example, multiply the following rational expression, and we have m minus n squared times over m plus n times the other rational expression, m over m squared minus mn. And what we're going to do simply is, I like to first we draw a long line, and we're going to have all the numerators here on the top multiplied, m minus n squared times m, and on the bottom we're going to have all the denominators, m plus n times m squared minus mn. Okay? But we need to factor out and simplify. It's not just enough to multiply and find the result. No, we have to, after we do the multiplication, or even before, you have to factor out and simplify. Check what can you factor out here. Well, this is already factored, so keep like that. And we have m, at the bottom we have m plus n, and here we can factor it out. We can factor m times m minus n, and we have a few things, a few factors that we can cancel, that we can simplify. M with m, and we have m minus n squared and m minus n exponent 1, right? We can simplify this by subtracting 1 from this exponent here on the top. 2 minus 1. Okay? The answer, the result is right here, m minus n exponent 1 over m plus n. And everything else was cancelled, was simplified. Cool. Cool, right? You have a very simpler rational expression result that was result from this long, very complex multiplication here. Objective number 4, dividing rational expressions. And to divide, the rule we will follow is this. We have the expression p over q divided by r over s is going to be equals. You're going to transform into, change into a multiplication. Is equals to p over q times, and then you reverse the second expression. What's the denominator here becomes the numerator, s over, and what's the numerator here will become denominator. And then this is the answer, this is the result, PS over QR. To divide by a rational expression, use the rule above, and then after that, you multiply as we have done before. We follow the step by step of the multiplication and simplify if possible. Divide, and we have x plus 3 squared over 5 divided by 5x plus 15 over 25. The first thing we have to do, well, keep the first rational expression as it is, don't change it at all. And the second one, you're going to transform into a multiplication. So you will switch, you will reverse. You're going to flip 25 over 5x plus 15. Now you can multiply. The way I like to do it in the multiplication, I like to just connect all the bars, the fraction bars like this, and to cover all the numerators and denominators, and we will multiply all the numerators, we will multiply all the denominators. But remember that we have to factor out and simplify. We need to find the simplest expression. Well, x plus 3 squared is already factored out, so x plus 3 squared, okay, keep it like that. And we can start, well, let's go on. Let's simplify the end. And on the bottom we have 5, and check this. Maybe we can factor out something from here. We're going to have the greatest common factor. It's common to both terms. 5 times x plus 3, right? That's pretty cool. Because if you check the numbers that you have on the numerator and the denominator, you're going to have 25. That is 5 times 5. You can simplify. And we have x plus 3 squared over x plus 3. There's a 1 here. That we can simplify this by subtracting these exponents. Sorry. The answer, when you check, we actually end up simplifying most of the factors, and the only thing that lasts is x plus 3. Cool. Another example. Now is a long one. We're gonna need to work a lot on this one. Divide. And 18y squared plus 9y minus 2 over 24y squared minus 10y plus 1 divided by 3y squared plus 17y plus 10 over 8y squared plus 18y minus 5. Well, the first step, the first thing that you're gonna do, you don't need to think a lot. Just repeat everything on the first expression as it is, don't change at all. And the second, you're going to multiply the second one, you flip, you invert, right? It's going to be the reverse. So 8y squared plus 18y minus 5 over 3y squared plus 17y plus 10. Now you're going to need to simplify. And this is going to be quite a work here, because you have several, you have 1, 2, 3, 4 trinomials. You have to find the factors that will make these four trinomials, I suggest you apply AC methods, and after we work out the AC method, and I can show you how to work at least one of these. Let's say you're gonna apply the AC method. Let's say for this one, A times C. A is 24 and C is 1. So A times C, 24. B is negative 10. So B, negative 10. You need to find two numbers that are multiplied, they are 24, and the sum of the numbers is negative 10. Oh, think about the two numbers, and 24 is going to be 1 times 24, 2 times 12, 3 times 8, or 4 times 6. Maybe 4 and 6, we can think about these two numbers, 4 and 6. And if we need to have negative 10 as the sum of the two numbers, then the numbers are negative 4 and negative 6. Negative 4 minus 6, negative 10, and negative 4 times negative 6, 24. So the numbers are negative 4 and negative 6. We will rewrite this polynomial like 24y squared minus 6y minus 4y plus 1. And we will apply here grouping, factoring by grouping. See? And then we can factor out 6y times 4y minus 1 minus 1 4y minus 1. And the result is going to be, I'm invading some space here, sorry about it. So 6y minus 1 times 4y minus 1. This is how we apply the AC method, and we need to apply for each one of these polynomials. This is going to be kind of hard work. I'm not going to show for each one, but for this, if we factor out, we will have 6y minus 1 times 4y minus 1. Okay? You need to apply this AC method, you need to factor out each one of these polynomials, and at the end, you will have the following. Let me show. I'm going to have here the following expression. 6y minus 1 times 3y plus 2 is this polynomial here, over 6y minus 1 times 4y minus 1 times, and we can put together all in one line, 4y, this one now, 4y minus 1 times 2y plus 6 plus 5, and here this now is going to be 3y plus 2 times y plus 5. Well, this is going to be hard work if we go over each one of the polynomials. Is a lot of time that we're going to spend. Not a lot of time, but some time. But to save, you can work by yourselves and try to find this out. But I'm going to keep it short here. Now we will cancel the common factors. We have 6y minus 1, and 6y minus 1, 4y minus 1, 4y minus 1, and 3y plus 2, 3y plus 2. Very cool. The things that are left, 2y plus 5 over y plus 5. That is going to be the answer, the solution for this. Let me borrow some space here. Is equals 2y plus 5 over y plus 5. Okay? And look, this is kind of a problem that you're gonna the whole thing to work this out is quite long. You need to work each one of these polynomials. But this is how it's done. And at the end, you can, instead of this very complicated, very complex division of polynomials here, you will end up with a much shorter, simpler rational expression equivalent. Okay? That's the whole point of this example. Now, let me clean this up because we will work on another example. Perform the indicated operations, and we have a series of operations here. We have multiplication and then division. And pretty simply, what you're going to do, if it's multiplication, you don't change the expression, just keep the way it is. Like here, the first one, x squared minus 25 over x plus 5 squared times 3x plus 15 over 4x. Now I have a division. Division can switch to multiplication and reverse the next one, the next rational expression. After the division sign, so we're going to reverse x over x squared minus 3x minus 10. Cool? And we can just put this all together. We multiply all the numerators, we multiply all the denominators. Look, this is something that we have to apply a few formulas. The first formula we're going to apply is here. Difference of squares, 5 minus x minus 5 times x plus 5. And here, the next, on this, we can factor out something. And the factor that's common to both terms is 3. 3 times x plus 3. And now here we don't have anything to factor out, just times x. At the bottom, check this. X plus 5 squared is already factored out. Don't need to change. Times 4x, cool. Times x squared minus 3x minus 10. This is a situation, this is a polynomial that you can factor out using the AC methods, for example. And the answer, the factors are going to be x plus 5, x minus 5 times x plus 2, right? Because a times c, negative 10, negative 10, negative 5 times 2, negative 10, and negative 3 is negative 5 plus 2, negative 3. Yes. Pretty cool, because we can cancel, we can simplify. Check this. X minus 5 with x minus 5, and we have x here with x, and we have, what else? We have x plus 5, and this is exponent 1, right? Just to understand that we are subtracting here 2 minus 1. That's how we simplify. And what else? What else can we simplify? I think that's it. This is all we can simplify Oh, I made a mistake here. This is a 5. This is a 5. So we can simplify here as well with this. Yes. And at the end, the remaining factors are 3 at the top. Let me borrow some space here. 3 on the numerator. And on the bottom, we have 4.
Plus that.
4 is remaining. And we have x plus 2. Now let's work on objective number 5, using rational functions in applications. Let's see an example for the ICL production company. The rational function Cx equals 2.6x plus 10,000 over x. It describes the company's cost per disc of pressing x per disc of pressing x compact discs. Find the cost per disc for pressing first 100 compact discs and then 1,000 compact discs. So let's find out. And we just need to apply this function. The function is for letter A, C of x equals 2.6x plus 10,000 over x. So on the first one, x equals 100. So let's change here. Let's substitute. Plug in x equals 100. 100 times 100 over 100. And you do the math, you're going to find as a result C of 100 equals 102. Oops. 102.60. $102.60. The next, letter B. What is the cost of producing 1,000 compact discs? So letter B. Now we are talking about 1,000. Let's add here 1 0 and now we have 1,000 over 1,000. And the answer is going to be in dollars. Do the math, you can use your calculator. 2.6 times 1,000 plus 10,000 over 1,000 equals $12.60. And very simple application of rational expressions in real life. Now another example. Let's say a company cost per book for printing X particular books is given by the rational function C of X equals 0.8x plus 5,000 over X. Find the cost of printing 100 books and C to print 100 books equals 0.8 times 100 plus 5,000 over 100. And if you do the math, type in your calculator, then you're gonna find out the answer to be $50.80. And the next one, for letter B. Now letter B, 1,000 books. C, cost of 1,000 books equals 0.8 times 1,000 plus 5,000 over what? 1,000. You can use a calculator, find the answer, do the math, and this is going to be $5.80. This is the last example of section 6.1. We have finished. Now, tell me, did you find the answer for our puzzle, the math puzzle? What is going to be the price of the combo? This is kind of like a system of linear equations, and you can find the price of each item, and then at the end you add all the items, you find the price of the combo. But let me show one way of finding it quickly. Check out how many items we have inside this box here. I'm drawing a box. How many items? Well, we have 1, 2, 3 fries, 1, 2, 3 drinks, and 1, 2, 3 burgers, right? 3 fries, 3 drinks, and 3 burgers. That means 3 combos. If the price of the combo is X, we have 3X here inside this box. And the price of the 3 combos is going to be 12 plus 5, 17 plus 7, 24. That means the price of each combo is 24 divided by 3, $8. $8 is the answer, is the price of each combo. Okay, thank you for watching, and I hope to see you on the next section.